Hello, welcome to another Science at Home. I'm Jerry Hull, I'm a Virginia educator, and these are my sons and my lab assistants, Liam, who's a 5th grader, and Julian, who's a 2nd grader. Today we're going to talk a little bit about matter. Matter is everything that's physical all around us, right? So what are the 3 phases of matter, the three states of matter?
Solid, liquid, and gas.
Right, solids, liquids, and gases. Everything falls under one of those categories. And matter is made of little particles called atoms and molecules, all right? So he hasn't had 5th grade science yet, but he'll learn all about it coming up. So liquids are, they flow and they take the shape of their own container. They take the shape of the container that you put them in. So I put water in this fish tank, and this fish tank is shaped like a rectangle, so the water inside is shaped like a rectangle. Where gases are less dense than liquids, and they spread out and they fill up whatever container you put them in. So the air all around us is, there's the same air up there as there is down here. Air spreads out. The molecules are spread out further, so it makes it less dense. So let's see what happens when you put air into a container. Julian, are you ready to try this? So let's see what happens when you put air into a container of liquid. He's going to use this pump to do this, all right? Go ahead and raise it up, all the way up. All right, so keep your eye down here.
I had training.
You want to do one more time?
Yes.
All right, so watch what's going on. So Julian, what's happening here? What's the air doing?
It's making bubbles and it's making the bubbles just go up.
Right, the bubbles go straight up because air bubbles are less dense than water, and they want to be on top. They want to be on top of the water. So knowing that, let's try something. I've got 2 pieces of bread here, and this is just regular old bread. Didn't do anything to it. And 2 solo cups, cup A and cup B. Now, I put some holes in the bottom of cup A, and there are no holes in cup B. I'm going to put some bread in each container. If you try to squeeze it in without poking holes into it, it should stay in the bottom of the container pretty well. All right, so you squeeze it in there. All right. And then maybe put a little bit in here. Squeeze that one in there. It doesn't matter if it has a hole in it. We just want it to stay in the cup. All right, so the bread is now in each cup. We're going to take cup A, and we're going to sink it down. Liam, I want you to carefully, without squeezing the cup, sink it down in there. Would you do that? And then hold it on the bottom. Okay. All right, so Julian, I'm going to move this down a little bit. Julian, you go ahead and put your hand on that and keep it there, okay? All right, Liam, do the same thing with cup B. Don't squeeze it, but carefully sink it down on the bottom. All right, so these cups are both on the bottom of this container. So, if we pull them out, we're going to pull them out carefully like this. Oh, pull yours out carefully. Keep going. Keep going, pull it out. Perfect. Okay. What happened to bread piece A? Go ahead and pull bread piece A out and show the camera. Oh, nasty. Bread is tasty, but this is just gross.
Soggy bread is on the gross food list.
Go ahead and don't put it all back in there.
Oh, it's disgusting.
Let's go ahead and put it on the counter there.
Oh.
So bread piece A got really soggy and disgusting, right? So Liam, your hands aren't dry though. So let me see. Let's dry your hands off a little bit and let's see what happened if the same thing happened to bread piece B. All right, you ready?
Yep.
Okay. Bread piece B is totally dry, right?
Yeah.
Taste all right?
Yep.
So
You just got my hands wet.
So nothing's wrong with bread piece B. You wouldn't want to eat that gross one. What's the difference here? What happened?
This one didn't have holes in it, and this one did.
And so what happened when the one that had holes in it? What happened with that one?
It either let out too much gas protecting the bread, or it just allowed more water flowing through the holes.
Well, it was the first one. So there's two good theories. It was the first one. This one, watch what happens. When you put this down, all the gases escape through the top. All right? They all escape through the hole. All the gas escapes through the holes. See that? This one does not do that because there are no holes and gases are less dense than water and they want to rise to the top. So the gas gets trapped inside the cup. When you pull it out, no water went inside the cup at all. Gases are less dense than water, and therefore they want to rise to the top. But you can trap gases inside something where there's air. This is how the first diving bells worked before they invented scuba, way back 100 years ago or so, where they would put a heavy metal thing down on the bottom of the ocean, and the scientist was able to be down there and the air would get trapped inside. So pretty cool thing. It's easy to do. You don't need a fish tank, just something that's big enough to hold water, a couple of cups, and give it a try. Let's hear what you might have to share with us about what you experienced. So try it at home and enjoy it. And don't forget, science is all
Around us.
around us.
Then stop.